Welcome. Today we're going to talk about something seriously powerful, the oxyacetylene torch. This thing isn't just a tool, it's more like a controlled force of nature. It can slice through steel, shape it, weld it back together. But to really master it, you've got to understand and respect the raw power you're holding.
So let's just get straight to the heart of it. How in the world do you control a flame that's burning at over 3,000 degrees Celsius? I mean, think about that for a second. That is hot enough to turn solid steel into a flowing liquid in just a few seconds. How do you manage that?
Well, the answer might not be what you think. It doesn't actually start the moment you put your hands on the valves. Real mastery, true control, that comes from what you know before you even dream of lighting that flame.
And that's exactly what we're going to break down today. We're diving into the 5 core disciplines, the things that really separate a beginner from a truly skilled and, more importantly, safe professional. These are the fundamentals, the absolute bedrock of doing this right.
Okay, so our very first discipline is the flame. Makes sense, right? To get a handle on this incredible heat, you first have to learn its language. You need to know exactly what kind of fire you're creating.
And here it is. This is your workhorse, your everyday go-to. The neutral flame. It's got that perfect, balanced mix of oxygen and acetylene. And the key phrase here is, will not contaminate the metal. That is everything. It means you're getting a clean, stable heat that results in a strong, pure weld.
But what happens if your mix is off? Say, too much fuel, too much acetylene. Well, then you get a carburizing flame. And the result is pretty bad. You're literally injecting unwanted carbon straight into your molten steel. That can make the final weld brittle, weak, a total failure if you're not careful.
Now, on the flip side, what if you have too much oxygen? That gives you an oxidizing flame. The best way to think about this is like you're creating a super fast, high-tech rust. It actually burns away elements in the metal, leaving you with a foamy, porous, and basically useless weld. So yeah, being able to spot these 3 flames by sight and sound, absolutely non-negotiable.
All right, so once you get a feel for the flame, you have to respect the power source behind it. And that brings us right to discipline 2. Understanding and controlling the hazards.
Just look at that number, 2,200 pounds per square inch. That's the kind of pressure that's sitting inside a full oxygen cylinder. It is a massive amount of stored energy that you have to respect every single time you go near it.
And this, right here, this is the biggest risk of all, a flashback. That's when the flame decides to burn backwards, shooting up the hose right towards the cylinder. This quote says it perfectly. Catastrophic results. We're not talking about a small problem here. We are talking about a potential explosion.
So, how do you stop that from happening? With these essential controls. Think of them as your layers of armor. The right PPE protects you. Identifying hazards prepares you. And those little things, the flashback arresters and non-return valves, they are the single most important safety device stopping that flame in its tracks. These are not suggestions, folks. They are absolute must-haves.
Okay, you understand the flame, you respect the hazards. What's next? Discipline 3 is all about the metal. See, the flame is only half the story. The material you're pointing it at is the other half.
And this is just so important. You simply cannot treat a thin piece of sheet metal the same way you'd treat a thick chunk of cast iron. One is going to warp in a second, while the other might barely seem to notice the heat. Knowing how that specific metal melts, how it moves heat around, that knowledge is what saves you from a warped, porous mess or a weld that just plain fails.
And that understanding of the metal flows perfectly into our 4th discipline, the technique. Using an oxyacetylene torch isn't a one-trick pony. It's a seriously versatile tool, but you've got to apply the right method for the right job.
This table lays it out perfectly. Look at the difference. When you're just heating, your goal is to be gentle, to coax the metal into straightening or expanding. It's all about careful, controlled heat. But cutting? Oh, that is a whole different beast. You're using a special attachment to unleash a blast of pure oxygen that literally burns and blows the metal away along a perfect line. 2 completely different goals that need 2 completely different approaches.
And that brings us to our final discipline. And honestly, it's one that too many people overlook. It's all about the details. A true pro knows the job isn't over just because the flame is out.
Let's talk about one of the most critical details, the gas leak check. It's so simple, right? Just some soapy water and you look for bubbles on all the fittings. But skipping this one simple step could lead to a massive fire or explosion hazard. And that last point, I mean, it should be obvious, but let's say it loud and clear. Never use a lighter or a flame to check for a gas leak. Just don't. And here's the bottom line. The job includes the cleanup. It includes the final inspection, and it includes the paperwork. This is your proof. It's the evidence that you did the job right, you did it safely, and you met the standard. It's the final stamp of a real professional.
And that's the thought I really want to leave you with today. Look, anyone can switch off a torch, but a true master, a real professional, understands that their responsibility goes way beyond that last flicker of the flame. So I'll ask you this. When you finish a job, is your work truly finished?